Welcome back to the channel. Today we'll be talking about encryption versus hashing, which is common in cybersecurity interviews. We'll learn about what they each are and how they're used. So let's get into it. So first we need to talk about what is encryption. Encryption is a two-way transformation. This is the most important thing to understand. When you encrypt data, you're scrambling it in a way that can be unscrambled later if you have the right key. To walk you through an example diagram, let's say you have a plain text which says, "Hello world." This is readable data. When you encrypt it with a key, it becomes ciphertext, something that is complete gibberish and unreadable. If you have the correct key, you can decrypt it back to the plain text to say "Hello world." This is the key characteristic of encryption, that it's reversible. You can go from plain text to ciphertext and back again. Next we'll look at some common use cases for encryption, starting off with protecting data at rest. When you encrypt your hard drive or database, that data is scrambled. When you log in with your credentials, the system can decrypt it so you can use it. Next is securing data in transit. When you visit a website with HTTPS, your data is encrypted as it travels across the internet. The receiving server decrypts it. This is the same with VPNs and encrypted email. Another example is confidential communications. Apps like Signal and WhatsApp use end-to-end encryption. Your message is encrypted on your phone, sent as gibberish, then decrypted on the recipient's phone. File encryption is another use case. When you encrypt a sensitive document, you need to be able to decrypt it later to read it. There are two main types of encryption, known as symmetric, which has the same key for encryption and decryption, and asymmetric, which uses different keys. But that's beyond today's scope. For now, just remember that encryption means that it's reversible. You can get your original data back. Now that we know what encryption is, let's talk about what is hashing. Hashing is completely different from encryption as it is a one-way function. When you hash data, you create a unique fingerprint, but you can never get the original data back from that fingerprint. Now let's look at the diagram. Let's say you have a password 123. When you hash it, you get something with gibberish, a long string of values. Now here is the critical difference. There is no way to reverse this. You cannot take that hash and turn it back into password 123. It's mathematically impossible by design. So let's look at some common use cases for this. The first is password storage. This is the big one. When you create an account, the website should never store your actual password. They should store the hash of your password. When you log in, they hash what you typed and compare it to the stored hash. If they match, you're in. This way, even if the database is breached, attackers don't get actual passwords. Next is data integrity. When you download software, you'll often see a SHA-256 hash listed. You can hash the file you downloaded and compare it to the public hash. If they match, the file wasn't tampered with during the download. Moving on, we'll look at digital signatures. This is when hash values prove the data hasn't changed. If you hash a contract today and hash it again next week, different hashes mean something changed. So remember that hashing means that it is a one-way transformation. You can never get the original data back, and this is by design. This is not a limitation. Now that we know what encryption and hashing is, let's look at side-by-side comparisons to really understand the differences. Reversibility is a fundamental difference. Remember that encryption is two-way. You can decrypt encrypted data back to its original form. Whereas hashing is one-way. Once hashed, you can never get the original data back. It's irreversible. Encryption's purpose is confidentiality. You're hiding data from unauthorized eyes, but authorized users can still access it. Hashing's purpose is integrity and verification. You're creating a fingerprint to verify that data hasn't changed or to compare against something without revealing the original. Encryption produces variable length output size. If you encrypt a 10 kilobyte file, you get approximately 10 kilobytes of encrypted data. If you encrypt a 1 gigabyte file, you get approximately 1 gigabyte of encrypted data. Hashing produces a fixed length output. Whether you hash the word hi or an entire encyclopedia or dictionary, if you're using SHA-256, you'll always get exactly 256 bits of output. Remember that encryption requires a key. It needs the key for both encrypting and decrypting. Without the key, you can't access the data. Whereas with hashing, it doesn't need a key. It's a mathematical function, so when you put data in, you get a hash out. Anyone can hash the same data and get the same result. With encryption, if you encrypt the same data with different keys, you get different encrypted outputs. With hashing, the same input always produces the same hash. This is called being deterministic. Hash password today, tomorrow, on any computer, and you'll always get the same hash value. Encryption's primary goal is to hide data temporarily. You can encrypt it for storage or transmission, and then decrypt it when you need to use it. Hashing's primary goal is to verify that data hasn't changed or to store sensitive data like passwords in a way that can be verified but never revealed. An example of encryption is when HTTPS encrypts your web traffic, or VPNs encrypt your connection, or when you encrypt sensitive files. Hashing examples include websites hashing your password before storing it, you verifying file downloads using checksums, or blockchain using hashing extensively. And here's the key to the interview question answers, that encryption is reversible and protects confidentiality, whereas hashing is irreversible and verifies integrity. They're not interchangeable, and using the wrong one can be a security disaster. Now let's look at a common real-world example of why websites use hashing and not encryption. The wrong way is encryption. Imagine that a website encrypts your password and stores the encrypted version in their database. The user creates an account with password mypassword123, and the website encrypts it and stores it in the encrypted version. And here's the problem. To verify your password at login, they need to decrypt it and compare it to what you typed. That means they have the decryption key somewhere. If an attacker breaches the database and finds that decryption key, they can decrypt every single password. This means that everybody's passwords are compromised. This is why encryption is the wrong tool for password storage. Now let's do it correctly with hashing. The user creates the account with password mypassword123. The website hashes it, and let's say it becomes another unreadable form. The website stores only the hash in the database. Now even if an attacker breaches the database, all they get are hash values. They cannot reverse these hash values to get the actual passwords. It's mathematically impossible. Now let's look at how login verification works using hashing. First, the user comes back to login and types their password. Next, the system takes what the user typed and hashes it. After that, the system compares this new hash to the hash stored in the database. Lastly, if the hashes match, the user must have entered the correct password. If the hashes don't match, then it means it's a wrong password and the login fails. Notice that the website never actually needs to know your actual password. It only needs to compare the hashes. Good websites use hashing with additional security called salting and uses algorithms like bcrypt to make passwords even more secure. And this is why understanding encryption versus hashing matters, because using the wrong one for passwords is a critical security failure that's gotten companies sued and fined. Now that we've outlined and explained the real-world example, let's briefly look at some common algorithms. I won't go into too much detail about each and every one of these, however I will let you know what you should know for interviews and certifications. Feel free to pause right now and take any notes or screenshots to remember these algorithms on the screen. For interviews and certifications, you don't need to understand the mathematical internals of these algorithms. However, here's what you do need to know. AES is the current encryption standard, with SHA-56 being the current hashing standard. Older algorithms like MD5, SHA-1, and DES are broken and should not be used. For password hashing specifically, use bcrypt or Argon2, and never use regular hashing algorithms. And again, you do not need to know how they work internally, you just need to know when to use each. And that marks the end of this video. Please remember that encryption means that it is a reversible two-way function, that hashing is irreversible one-way function, and that you need to choose which one to use based on a need, not a preference. As always, thank you for watching, and please have a nice day.